Hi all, good morning and good afternoon to everyone who is here. So from the screen and from the invite, I think you were able to know the topic, and it's microservices and domain-driven design. And in this session, I'll try to cover how a microservice is being designed and how a domain-driven design is being used for the design purpose, and how the challenges at the designing of microservice can be overcome. So all these things I'm trying to cover in this session. So I think we can start now. And before we talk about microservices, I would like to bring you something about the monolithic application approach that we currently follow. So the monolithic application is something where all the modules as packed as a single deployable unit. So as a diagram, we see this is a single pack of user interface, business logic, data interface. So everything is as a single service, and there will be a single database communicating. So this will be useful for different scenarios, like if we have a small team to work on a particular business logic or a particular application. So it will be good if we use this monolithic approach. And if we have a small business logic, that the best way is to use this monolithic application approach, because it will help us to avoid the designing time and all. So some examples are like the MVP creations or POC creations. So the best way is to use monolithic application approach. And there are a lot of disadvantages in using this monolithic application approach when we have a complex business logic. So that are the like the scalability. So as we know, this is a single piece of code or a single piece of service. So if you want to scale individually, or if you want to scale only a particular part of an application, it is impossible. We need to scale the entire system, and it is costly one. And the maintainability, so there are a lot of coupling and hidden dependencies will be there for this entire set of code, and it is hard to maintain. When we think about a new technology, so we cannot introduce a new technology into a particular portion of the application. So the whole application need to be rewritten. Then about testing. So for a small changes, we will be having a lot of regressions, and regression testing is required. And there is a possibility to miss some kind of regression testings and can introduce vulnerabilities. And it will take more time to debug an issue or build a new version, as you know that code is too huge. And the same is for how a new developer or an existing developer understand the same code he written after a long period of time. So to overcome the problems, we can use microservices. So microservices, as a name suggests, it is short. It should be short, and this is a kind of application pattern we will follow for the microservices approach. There will be individual database for individual microservices. It's not like same database communicating to multiple microservices. We can create in that way also, but it is not the recommended way. So there will be separate database for separate microservices. So the whole complex business logic will be divided into smaller chunks of microservice. And while we doing that, there are a lot of advantages. So first of all, the development, issue fixing, and deployment, everything is happening independently. So we can make each team autonomous. So each microservice can be developed by an autonomous team. So there is no dependency with them, and they can use their own terminologies and when they're working on them. And it is isolated too. So each service is a different process. It's not a single process, and inside that we have different set of subsystems. It is entirely different. So 1 second, I can see a raise. Okay. Sorry. So when we think about isolation, so each process is a different process and is having an isolated individual database. So we can say this entire system, each microservice is isolated. And when we think about the scalability, so since it is isolated, it is very much easy to scale individually. Each component can be scaled. So next is faster development. So each microservice is short. For any new enhancement inside that microservice is will be very easy to integrate in shorter development cycles, and it is highly aligned with the agile development methodologies. So the releases can be made really faster. And when we think about the failure, so when a monolithic application fails, the entire application is down. But here, if some certain scenarios, if an application fails, it doesn't make the whole app fail, because it will affect only that particular microservice. So debugging and testing. So each microservice will be run by a different team, and each microservice have a different QA. So the testing is more coherent and consistent here. And since the shorter piece of code helps us to spend lesser time to do the debugging. So these are the advantages, but even if we have this much advantages, there are certain challenges definitely there to develop or design the microservice. The first challenge is, like we said, we will be creating different set of microservices on top of a complex business logic. So we should have a thumb rule in our hand to decide what a service should do and what it does not do. And also, it is very difficult to create boundaries between microservices on a complex business logic. And there is another disadvantage. There is another challenge in this, is like the communication. So previously in the monolithic application, we have a single application, and if we export a public method inside a class, it can be called and access the different modules. But here we have individual pieces of microservice as an individual services itself. So the communication is definitely we need to take care. And the same for the deployment. So we will be having n number of microservices, and each microservices need to be scaled in a different way. So these are the challenges, and the first two challenge that to design the microservice. So we can overcome that by using domain-driven design. So domain-driven design is something which is introduced by Eric Evans. So it concentrates the development on a business logic. So it will give more priority to business logic than anything else. So it centers the development on programming at the domain model. The domain model is something which has all the rules, all the logics which is there inside the business or the business code. And we will use this domain-driven design to decompose the whole complex business logic into different pieces of information, where a common person who is a technical one, who is non-technical one, can understand. So that starts with a ubiquitous language. So this is a common language or common vocabulary that is being shared between all the stakeholders at the time of the design, or who all are participating in the design. They will share this common vocabulary. They will identify the relevant modules in the monolithic application, or we can say from the entire set of the business logic. And they will apply the same vocabulary so that all the different parts of the modules, even if it is having a different business functions or business units, they will be represented in a same common way, or using a common language. Then the important component of this domain-driven design is domain services, because all the business logic will be handled inside the domain services. And this domain services has a lot of components, and we can say different building blocks of domain-driven design as domain model, entities, value objects, aggregate, root aggregate, and different services, which include the domain services also. So anything and everything that is related as a building blocks, that comes under the domain service. So this is a small architecture of a domain-driven design application. So we will be having an application layer in the front and domain services in the center. So that deals with the core business logic, and it is isolated with the database or infrastructure layer. So all the UI or any other inputs coming from the outside world will be hit in the application layer, and application layer will choose how to process that particular code. If they require any business logics, if that doesn't require, they can directly communicate to the repositories. If they need any business logic, they will come to this domain service. So those decisions will be made by the application layer, the application services. And when we think about the building blocks, the main building blocks or major building block starts with the domain model. So actually, we can say domain is a problem. It's a problem of the business. So wherever we see domain-driven design, we can relabel it as business problem or problem-driven design. So since there is a problem in the business, we are trying to arrive at a solution using GDD. So the solution can be named as model, and this domain model will contain all the data of this problem. Like it will be in an organized, structured way too. And we can say it as an abstract model of the business domain. So that means it will contain all the business logics or all the requirements. In a simple way, we can say requirements. All the requirements will be there in that model in an abstracted way and in a readable way for both a technical and non-technical person. So next is a building block is entities. So entities is anything that have a data and a behavior inside the domain model. We will call it as entities. An example is an order class. We can order is something which is inside the e-commerce. We can think of it that way. And entities are the attributes which is there. It's the data entities, and the behavior will be the methods which is there in the order. So like adding an order item or deleting an order item. So these are the behaviors. And there will be certain business logics that pertaining to this entity. That means any business logic that we need to perform before we create an order or we delete an order. So those things we have to add it in the entity class. It should not go outside the entity class. And finally, this entity has an identity. So there should be ID property. So using that ID property, we can access this entity, and it will be maintained throughout the lifetime of the application. Then comes the value object. So the value object is something which doesn't have an identity. So since it doesn't have an identity, that means it cannot live alone. It will be attributes. Most of the time, it will be an attribute of an entity. Even if it doesn't have an identity, so it can have the business logic that is associated with that. An example is the address. That is for an order entity. Definitely when we do an order, there should be an address. And address will be having different attributes like street, city, and location, and different names will be, different attributes will be there. So this we will keep as a separate thing from the order, but this cannot exist alone without an order. So that's why it say doesn't have an identity. But any business logic related to address will perform or will be handled inside the value objects itself. And this is one of the major thing which is there in the building blocks is aggregate and aggregate root. So we said we will there is entities and value objects we discussed, but there will be hundreds of entities inside a business domain or a business logic. And there should be a way to group them. So we will be using aggregate to group this cluster, group it as a cluster. And also we will ensure data integrity inside the domain model using aggregate. To maintain the data integrity, we have a concept called aggregate root. And aggregate root is the only interface that we have for all the entities and domain objects inside the aggregate. So there will be so this is an example for aggregate and aggregate root. So buyer is an aggregate, order also an aggregate. Aggregate having one entity, this is buyer. Order have multiple entities. This order itself is an entity, but it is an aggregate root because it is exposed to the outside world. Order item is a child entity but it is not exposed. That means any behavior or any methods that we need to apply on order, then it should be exposed in order aggregate root. So if you're doing this in this way, advantage is like it will maintain consistency. So any change, it will happen only through the aggregate root. So the consistency is maintained like if any change we apply directly, it's something like we lose a leg of a table. And as a word defines aggregate root, it should have only one aggregate root. A aggregate should have only one aggregate root. You can consider it as primary entity or the root entity, anything. So it should have only one aggregate root. Then we have a lot of services, as I said. So we will be having domain services, which is there in the domain layer. Application services will be there in the application layer, and repository services will be in the repository layer. The domain services will be something which there will be certain set of code blocks or certain set of behavior that needs to be shared between entities. So those behaviors or those methods will be added inside the domain services, and all the business logics that related to that behavior will be handled in the domain services. So any methods require access to the repository. So there will be certain methods that we need to perform before we do a database operation, but that is common. So those things also will be there in the domain services. Then comes the application services. That's, as we saw in the architecture diagrams, it's about the domain model. So it coordinates the application activities. So it decides what a request that comes to that particular layer should do, should not do. And of course, it doesn't have any business logic, and there is no knowledge of states since it is isolated from the domain. There is no information of the entity states. Then comes a repository service. Definitely there will be a database. We cannot create an application without database. So all the entities that we defined in the data model or in the domain model, definitely it will have a database table. So that table will be handled in the repository. So all the classes that is related to the database will be there in the repository. That helps the domain model free of infrastructure concerns. Any, like in future, if you are changing a database, we only need to create a new implementation for that particular repository service. It doesn't require any kind of changes in the domain model. So the design should be like that. So these are the basic things which we need to know when we think about domain-driven design. And next comes how we identify microservices using DDD. So we have 4 different steps. Like, first of all, we need to analyze the domain. So all the functional requirements we will be converted into a domain model diagram. Then we will define that bounded context inside that. That is a major part. And we will apply the domain driven design patterns, like we will identify entities, value objects, aggregate root inside the domain, inside the bounded context. And we will use that bounded context as a microservice. So we will go one by one. So first of all, analyzing the domain. So this is one of the important tasks. It will be done by a group of team. So we initially said it will be a team with non-technical and technical people. So the non-technical people will be the domain experts. There will be BAs, and also the technical people will be the architects and developers. And we said about the ubiquitous language. Then they will explore on the requirement, and they will map all the business functions with connections. So when we think about e-commerce, there will be a lot of connection between like to happen to a particular department to work. So there is a small diagram I have included. So this is a diagram that we designed as part of the analysis of the domain. So we can see there is a particular business challenge can be considered as a business unit. So there comes the order, payment, and delivery. There is a single department, and that department will have a lot of connection with other department. Like they need to know about product, they need to know about inventory, whether data is there or not. So those kind of connections and those things will be designed in this discussion. and identify the subdomains. So subdomain, we can say order will be a subdomain, payment will be a subdomain, delivery will be a subdomain. So all these things will be identified. And what is the core subdomain? What are the related subdomains? So that is related to the business function connections. From the connections, we will be identifying the closely related subdomains. And then comes up with the diagram. So there is no certain rules to design the diagram. So the diagram should be understandable to all the stakeholders who are participating. That's only thumb rule. So it's a rough sketch. And finally, just a heads up, like we are not thinking about any technologies at the current point. At the analysis domain, not thinking about the technologies. And this is some kind of the diagram that people may draw. Then about the bounded context. So this is the major thing which we use to analyze or identify a microservice from the above discussions. First of all, bounded context is basically a logical boundary between the entire set of business logics. So the problem is how we define the boundary. There will be a set of rules we need to keep it in our mind. One thing we need to keep is like there will be same set of data which require different representation in different parts of the application. An example is the product. Product in the diagram is its core part will be there in the catalog searching, but the product will be used in other areas of the business also, like in the orders, inventory. But we should not maintain different, like we should not maintain a single representation for the product and use in the different set of areas in the business logic or in the business domain. The problem is like we need to like include all the complexities of all the different modules there. So we should create separate items for separate models for each of that items. Then we should not think that each bounded context is isolated. So there will be a way of communication, because previously we have a single application when we think about monolithic design. So it's just exposing a class. We can use the methods there to access the functionalities. But here it's individual bounded context. So we have think that there is no isolation. And we cannot say every time this bounded context is aligned to a subdomain. So there will be certain cases where one bounded context has multiple subdomains. And this bounded context should be aligned to business capabilities. This is a major thumb rule we have to keep in our mind. And this part will be majorly taken care by the domain experts. Because in future, if we have any kind of enhancements, it should not affect the bounded context. It should come inside the bounded context itself. And there may be situations we will break a bounded context into two different sets, but still it should be easy to do. So those things definitely need to be taken care by the domain experts. And finally, we will use this bounded context to create microservices. That means each individual microservice, individual domain for the bounded context will be each microservice. So from the previous e-commerce diagram, so we can consider these are the different bounded contexts, and is aligned to the subdomain here in my example. And each these bounded context and with some events we can consider as a microservice. And next set of challenge we have is the communications in the microservice. So we have two ways of communication in microservices. One communication is synchronous, another is asynchronous. The synchronous way of communication is like which is there with the monolithic application too. But the only difference here is like in monolithic application, we will be communicating directly to the application. But here we need an API gateway because we will be having a number of microservices. And each microservice, if we ask the UI to communicate individually, then it is not a good approach, it's a weird approach. So we will have an API gateway there. So all the HTTP requests from the UI comes into the gateway, and any common logic we need to perform, not business logic, it might be some generic logic, something similar to this we see here. We have an authorization and authentication microservice. So these are generic services. Apart from the supporting microservices, we will be having generic microservices. So those things I think we can handle here in the API gateway. And communication between microservices, it is not recommended to use the HTTP or synchronous communication, any kind of other synchronous communications. But there will be certain situations where we forced to use a live communication, where we require a live response. An example is like when we go to this order. So we have an orders microservice. Imagine if we have a printing microservice that prints the invoice of this order. So once this order is done, the invoice needs to be generated immediately. So we cannot wait for an asynchronous communication there, where we should use this live response. So we should use this HTTP or any synchronous communications. So other and communication is asynchronous communication, and the best way of using asynchronous communication is event-driven architecture, or using publish and subscribe. So what happens is like one microservice publish an integration event, and another microservice will subscribe that. And the problem in this approach is like each microservice is being developed by an autonomous team. That means that team doesn't know what the other team is doing. So their terminologies will be different, but it's only a possibility. But still we need to address that possibility. So we will be using an event bus as an interface. So event bus is an abstraction or interface, and it has the API implementation for the publish and subscribe using a message broker like Kafka or RabbitMQ. And then what happens is like, this is an example which is being given here is a user profile microservice is there, then a basket microservice is there, and ordering microservice. The user profile microservice will create the user, and it will have a lot of properties for the user. And the same user will have a different representation in basket microservice and ordering microservice. So the user profile microservice will publish the user, any information that is user created, user updated, with minimal amount of data that is allowed to expose. And the basket microservice and ordering microservice subscribe that. And this user microservice is not aware whether there is some issues occurs there, because it doesn't want to know, since it is a different microservice. That is how this event-driven architecture works. Why it is called event-driven architecture is because this is happening using events, and when the basket microservice gets this user, it will do some logics there, and it will create maybe a different entity there in that microservice. It will trigger another event, and this will happen as a chain. So that's why it is called as an event-driven architecture or event-driven communication. So these are the two ways we can use for the communications in the microservice. The last thing is about the deployment. So deployment, I'm just telling about a high level only. So we should use Docker and Kubernetes for the deployment of the microservices, because we know we have n number of microservices, and each needs to get deployed. So if we should use some kind of automation ways to do that. So first of all, why we use Docker is like Docker itself will create a virtual environment. So that's the actual purpose of Docker. So it is something like it doesn't have any dependency on the OS or the software that we need to install as part of a microservice. Everything will be there inside the Docker image. So only thing is like we need to create a Docker image and run the Docker image in a container. So at the time of deployment, only we will think about a container instance, and we will deploy this image inside that container instance. So when we think about scaling, it is done based on changing the number of containers. So if we want 10 or 10 individual instances for a particular microservice, we will use 10 different containers, and we'll be using the same image for all these 10 containers, because image building is only thing which is having a time consuming thing. So building, deploying, starting microservice, all will be faster if we have an image. So in case if we have a horizontal scaling that needs to be happen on a real time. So it is very easy and it is very faster because already the image is there. Only thing we need is to deploy it in a new container. Kubernetes is something we will use as an orchestration of these Docker containers because it's a kind of automation we do for this Docker container deployment. So how many containers we require for a particular microservice, everything can be configured in Kubernetes. And it also offers a collocation of containers and replication control. Collocation means you can place all the containers in a single space and you can divide it using a namespace and all. So that's a little more technical. I'm not going to that now. A replication control, like it maintains the number of container instances and all. So definitely if you think about microservice architecture, we should think about Docker and Kubernetes, and we definitely require some help from the DevOps team. And as a summary, so what I try to express or I try to say in this presentation is like, we should use microservices for complex business use. We should not think about monolithic application. Then when we use microservice design, even if we are not microservice, if we have a complex logic, definitely domain-driven design is the best way to decompose that. And if we need to define the boundaries or define microservices, the best way or the only way we have is the bounded context inside the domain-driven design. And as I said, like even if we have like a big complex business logic and we don't have a better team or a team with a less number of people, it's not that good to choose microservice architecture because it will create different problems. It will slow the entire process. So if you have a good team, and only then we should think about microservices. Then another thing is definitely we should not say that monolithic design is not a valid or good one. It has certain set of areas where we should think only about monolithic applications like POCs or small scale applications, where we know the domain won't expand further. Next is how we communicate. It's using event-driven architecture and live communication. I think we spoke about it previously. It should happen to HTTP. So that's a thumb rule we should think about when we design the communications. And definitely Docker, Kubernetes, and some help from the DevOps side is definitely required to reduce the complexity. We cannot say that complexity is completely removed, but it will definitely reduce the complexity of the deployment architecture. And that's a summary that I have for this domain-driven design and microservices. Finally, thank you all for being part of this session. And if you have any questions, I think I'm late by 3 minutes, but still, if you have any questions, please ask.
Do you want me to read it?
Sorry?
There is one question in the chat window. I can read it. It says, okay, are gateway, router, and event bus part of application services? Or every microservices uses application services like API endpoints?
Okay. So this application services is something which comes inside the microservice. So I think the question is like, just a second, I'll read that. So are gateway and event bus part of application services? First of all, no, it's not part of this application services. Application service, maybe I can go to that slide. So here it is. So application service is something which comes inside the microservice, and this gateway will come outside the microservice, and also the event hub that also that comes outside the microservice. So that is a different set of areas. And next is only or every microservice application service like API endpoints. Application service, basically each microservice has all the API endpoints will be defined in the application service. Yes, you said is correct. And the final point is like Kubernetes is not the only one technology for node collaboration. Yeah, I agree that it's not the only one technology, but I said that is one way we can reduce the complexity of deployment. I hope I answered your question. Is there anything more?
One more question from Jose.
So is it like event bus can be seen as a circuit buffer? How it take advantages of MongoDB for persistent in case of blackout and is really needed MongoDB? So basically, like event bus doesn't have like that kind of advantages what we have with MongoDB. So event bus it's a kind of interface. So where we can have the implementation with either these brokers, or if we have the option to do it with MongoDB, then definitely we can implement the interface there with the MongoDB too. So next question is from Rohini, I think. So it's like mobile app authentication, which is better, synchronous or asynchronous? So authentication, I think it should be synchronous. So once the authentication is passed, only then we can move forward, right? So I think I understand in that way. So correct me, Rohini, if I'm not telling in the right way. So authentication should happen inside the API gateway. So irrespective of what client it is, so it should happen inside the API gateway, and it should be synchronous. It can be triggered by the event as well. Sorry, Rohini, I didn't get. Are you connected something with what Jose Antonio said, or is it something what you said about your point? Yeah, it can be triggered by event. It's not like it's not an impossible thing, but the recommended way it will be like it's a synchronous thing, is what I understand from the authentication. So from I think what I understand is mobile app authentications like it will be again an API that comes from the mobile application. So the authentication will be handling in the same layer, and it should happen in a synchronous way. I said it should, but there is a way to do it using events also.
Hito, there's another question in the Q&A model.
Another question, where is it?
In the Q&A model, down on the screen.
It's in a different channel?
It's
oh yeah, got it.
Yeah.
Cost increases. How much of a cost increase is there due to each microservice have its own database? As a bit of background, in my company, we discussed the idea of developing backend using microservices, and I'm curious what having more DBs, for example, more instances or on AWS, would mean for the client cost-wise. I'm not that sure about the cost thing, but there is an option where we can use single DB server to create multiple DBs inside the same server. We think about the cost. What I know about the cost thing.
I think we're okay.
Okay,
There are no
there's a
more questions.
question. So this best way to get started. So sorry, Akshay, Deva. So I didn't actually completely got that question. Can you please elaborate a little? Okay, as a new buy. Sorry, Akshay, I'm not getting this.
I think it means that what is the best way to get started with microservices and domain-driven design if you want to get the basic information.
You mean to say best links which you have, or the best documents you have to documents you need? Yeah, definitely there are a lot of tutorials. There is which maybe I can share to you. Is that fine? Okay. So I'll share my email ID here. So please shoot an email to that, and I will respond to all the queries there. Akshay. So another question is from Arjun. Will the future be serverless microservice architecture? Definitely, we should think about serverless because it will reduce a lot of costs for sure. But it's not there in the current scope of my presentation. For definitely, the future will be like that. Now also we have a lot of people doing that with microservices. Also with monolithic applications, we are using serverless things supported by AWS and Azure, and definitely that is a future. Okay. So I'm just sharing my email ID here. So if you have any further questions, or if I didn't answer well any of the questions which you have asked here, please shoot an email. I think I have shared it in the webinar chat. So please shoot an email to me, and I will try to resolve. Okay, thank you all.